Importance of earth science. First, let's talk about what science is, or what is science. Science is a method for studying and understanding the world. Comes from the Latin term scientia, which means knowledge. So really, science is a way to gather knowledge through studying and developing an understanding of the world around us. So science is a process based on inquiry. So you ask a lot of questions that helps develop explanations about events in nature. Science also assumes that nature follows a set of rules that can be understood. So we assume that there are these rules that if we study enough and we ask enough questions, we can figure out the rules. Science is not a set of just answers to everything. Science is what we call tentative, which means it can change based on new information. So really, it's an understanding of the world based on our current information. So if we get new information, we have to change our explanation and our understanding of things based on that new information. So science is not set in stone. So research and technology. So the study of science, including earth science, has led to discoveries that have been applied to society's needs and problems. There are two basic types of research. Well, there are really just two types of research. We have basic research, which is carried out just for the sake of expanding knowledge. We conduct basic research just to see how things work, just to see what happens if you do this, that sort of thing. You don't really have a plan for how to use that research. You just want to see how something works or what happens if you change something. Applied research is carried out to solve a specific problem. So we have a specific problem. We have applied research to solve that problem. So for example, from earth science, hole in the ozone layer, research is conducted, figure out that chlorofluorocarbons are reacting with ozone and ultraviolet light and breaking down the ozone. So we apply research then to solve that problem. The answer to that was remove CFCs, or chlorofluorocarbons. Technology then, but that's applied research. Applied research, you have a specific problem, you're researching that problem. Technology is the application of scientific discoveries to create products. This really gets into engineering, really. Technology, engineering is kind of the same sort of thing. I always like to tell people, if you like science but you don't want to do research and study things, well, get into engineering, because you take a lot of what scientists have discovered and you apply that to creating things or building things or whatever. But technology is transferable. It can be applied to new situations. So we can take technology from one area and apply it somewhere else. Some examples of technology. So we all have an idea of what technology is, but really, if you think about it, like pencil and paper is technology. Books are technology. But we kind of think of technology now as like high-tech stuff. But the study of earth science, especially the space program, has given us new technology. So freeze-dried foods, because it costs a lot to send water into space. So if it's dried out, it's easier to send up in space. Ski goggles, laptops, tablets, phones, basically all of our electronics. Ultralight materials, because again, when you send something into space, the lighter it is, the cheaper it is to send. Smoke detectors, various other detectors. Some of this technology can make life easier and safer. There are some disruptive technologies, though, which have actually made life harder for some people because it did away with some jobs and stuff. But some examples here, though, you have like a USB drive. Okay, like a little thumb drive here. You could actually add cloud storage over here now, but this replaced a save icon. No, it's a floppy disk. So this is an old 3.5-inch floppy disk. These held a whopping 1.44 megabytes of information. I think I did the math on this, and it would take several hundred of these just to back up part of a phone. So, but cell phones, smartphones in particular, have replaced pagers. Email replaced regular mail, and office memos. So these are some disruptive technologies. So just give you an idea of what different technologies there are. Impacts on society. So we get better predictions of potential disasters. So this can help save lives and property. Can help map damage and direct resources after disasters. So we have meteorologists that track hurricanes and decide where they're going to land. We can have sensors to check for and detect earthquakes and volcanic eruptions, things like that. Can help us understand our place in the universe. Sort of, we are here somewhere in the outer spiral arm of the Milky Way galaxy. By the way, this is not an actual picture of the Milky Way galaxy. We have not got a spacecraft far enough away to actually get a picture of our galaxy. So this was a neighboring galaxy. This might be Andromeda or something, or it may just be an artist rendition. But the idea is that we are sort of in the outskirts of the galaxy. Environmental monitoring, again, watching to make sure we're not polluting streams and groundwater and air and things like that. Wise resource use, kind of having an idea of how much is left of something and trying to use it wisely. And improve farming methods so we can grow more food to feed the growing population. And earth science can also have impacts on our worldview. Okay, so for example, ancient people had a very limited view of their surroundings. Basically, what was in their valley and the surrounding hillsides, that's all they knew. So it kind of started there. Now we have a very clear image of Earth. We know it's a sphere floating in space, going around our sun. It rotates every 24 hours on its axis. It takes a year to go around the sun. The sun's going around the center of the galaxy, etc. So we have an idea of what the Earth is. We also know that our solar system is not the only one. There are other solar systems. This was a big question. It was answered just really a couple decades ago, that we found planets around other stars. That was a big question for a while. We now have pictures of other solar systems being formed in their infancy, etc. And we now know that humans have also altered the environment. We know that, things that we have done to the environment have altered it. So some major recent events in Earth science. So in 1907, using radioactive decay, Earth was determined to be billions of years old. This led to the first accurate geologic timescales. It's actually 4.6 billion years old, best we can tell. In 1913, the ozone layer in the upper atmosphere was discovered. This was proposed to protect the Earth from sun's ultraviolet radiation, and that is actually, as far as we know, what it does at this point. In 1925, analysis of the spectra of stars reveals that hydrogen and helium are the most abundant elements in the universe, because stars are a major component of the universe, and stars are mostly made of hydrogen and helium. In 1936, using seismic waves, it was determined that Earth's center consists of a solid inner core and a liquid outer core. So we didn't know that until it was less than 100 years ago. In 1962, the foundation for plate tectonics, or the plate tectonic theory, comes from Harry Hess's hypothesis of seafloor spreading and other discoveries on the ocean floor. In 1990, the Hubble Space Telescope begins exploring Earth's solar system, measuring the expansion of the universe and providing evidence of black holes. In 2004, sediment cores from the ocean floor reveal atmospheric and climatic history from 55 million years ago. So we use sediment cores and ice cores to see what the atmosphere looked like millions of years ago. In 2015, the first observation of a gravitational wave was made. These were predicted by Einstein back in 1916. So it took over 100 years from the prediction of, or right at 100 years, from the prediction of gravitational waves to observing them. And then it's not on here, but in 2021, the James Webb Space Telescope went into orbit and started collecting information. Actually, just started collecting. Starting to get images back now. They had to calibrate it and stuff, but it is an infrared telescope. but we are just now getting information back from it. So we'll see what that brings.